the topic which I today learn you, that electric dipole moment and dipole. And don't waste your time, we shall start my lecture, which is my lecture is electric dipole. So what is the electric dipole and what is its necessity? In our daily life, we often see electric dipole. That is the molecule like H2O, HCl, C2H5OH, that is ethyl alcohol, acetic acid, CH3, COOH, all belongs to electric dipole. So every electric dipole produce a separate electric field. We shall now discuss with some special case of electric dipole. So to know about the special case, we first go with the definition of electric dipole. So what is electric dipole? When a negative charge minus q and a positive charge plus q are separated by a small distance, let's say 2a, then a dipole is formed. Now, the dipole moment, what is called dipole moment? The dipole moment is the product of the magnitude of any charge, that is, here we can say only q, multiplied by the distance between them. So we can say the dipole moment P equal to q multiplied by 2a is the magnitude of dipole moment. But the direction of P is from negative to positive, that is from minus q to plus q. So we know that the dipole moment is a vector quantity whose direction is along from negative to positive charge. So dipole moment gives basically the strength of dipole. Which dipole is stronger and which dipole is lesser, we can know by the measuring their dipole moment. It is depends on the magnitude of the either charge, not the sign plus or minus, the magnitude of charge and the distance between them. So dipole moment is a vector quantity and its unit is, as charge unit of charge is coulomb, so coulomb meter, cm, that is coulomb meter is the unit of dipole moment. Now we can show the dipole of a charge of two charge separated by a distance at an point, axial point. So we can go with the calculation for dipole moment in axial point. Now what is axial point? Suppose this is minus q charge and plus q charge are separated by a distance 2a, and the direction of dipole moment is from negative to positive charge, always negative to positive charge. Now axial point means if this is the axis of the dipole, then a point, if we take a point on the axis at some distance r from the center, at some distance r from the center of the dipole, that is we can say it O, then it is then the point P is called at axial position, that is with the axis of the dipole, minus q plus q. So the point P is now on the axial position of dipole, as it is in the same line of the axis of the dipole. The axis is, this is the axis of dipole. So as this is the center of dipole, so the total distance is 2a, so every distance, so the distance of every charge from the center is a. Now we can see that the E1 or E, as we say that E minus q, that is the electric field due to minus q charge at point P is given by 1 by 4 pi epsilon naught into minus q divided by the distance is a plus r, that is a plus r square into p cap, where p cap is the direction, of the dipole of the electric field from minus q to plus q. As we can say that the direction is along this direction, sorry, along left side. The direction is along left side, sorry. The direction is along left side, because we know that the direction of negative charge, direction of electric field due to negative charge is always towards the negative charge. So the direction of E minus Q is towards left. Now we can go with the electric field due to positive charge, that is 1 by 4 pi epsilon naught Q or plus Q by, what is the distance of plus Q and P? Now this distance is R and this is A, so this is R minus A. So we can get R minus A square into P cap. Okay, where P cap, now the P cap or the P cap is the direction from negative to positive charge, and here the direction of E of plus Q is along towards positive side. E minus Q and E plus Q direction is towards positive charge, because the direction of electric field due to positive charge always goes away from it, and the direction of electric field due to negative charge acts towards the negative charge. So the electric field E of minus Q is along the direction of left side, and the electric field due to the positive charge is along the direction of right side. So the direction are opposite to each other. Now the resultant electric field E is given by E minus Q plus E plus Q. But as their direction is opposite, so we can get the resultant electric field is the E plus Q minus E minus Q. As the denominator is A plus R and the denominator is R minus A, or it is R plus A, so E plus Q is greater than E minus Q. So if we put the difference between these, so what we can get, the resultant electric field is given by E equal to 1 by 4 pi epsilon naught Q divided by R minus A square minus 1 by 4 pi epsilon naught Q divided by R plus A square. So 1 by 4 pi epsilon naught R minus A square R plus A square, that is R minus A, Q is common, so R minus A is R plus A square minus R minus A square. So we can get Q divided by 4 pi epsilon naught A plus B square minus A minus B square equal to 4AB, that is 4RA divided by A minus B, A plus B and square, that is R square minus A square and square. So now the dipole moment, we know that the dipole moment P equal to Q into 2A or 2AQ. So we can get it as 2QA into 2R divided by 4 pi epsilon naught R square minus A square whole square. So we can say that the value of E equal to 2QA is P, that is 2PR divided by 4 pi epsilon naught R square minus A square and then square. So the resultant electric field at the axial position of a direct dipole is given by 2PR by 4 pi epsilon 0 is given by E equal to what we can get 1 by 4 pi epsilon naught 2PR divided by R square minus A square, which is act along P, because here the E plus Q is greater, so the direction of E plus Q is along this direction, that's towards right, and the dipole moment is also along negative to positive direction. So here the resultant electric field direction is along the dipole moment. So this is the final expression for axial position of electric field due to any dipole. Now, if the distance between the dipole is lesser, the distance between the dipole, that is 2a, is much lesser than the p, that is p is situated far away from the dipole plus q charge or the dipole, then for r much greater than a, E equal to 1 by 4 pi epsilon naught 2pr divided by, as a is negligible to r, so this time, sorry, here an square term is here, so this term is r to the power 4, or we can get E is equal to 1 by 4 pi epsilon naught 2p by r cube, and the direction is along p, that is from negative to positive charge. So this is the final expression of a dipole, and this is for short dipole. If a is much less than r, the r is much greater than a, then it is called a short dipole. So this is a special case, and this is the in general expression. Okay, please write down. If you have any problem in or difficulty to understand this, please write in my comment box. Okay, now we shall go with number 2 example, that is the electric field of a dipole moment at a point equatorial position of a dipole. Number 2 is electric field due to a dipole at equatorial position. Equatorial position. The derivation is very common in your HS exam. Okay, so understand it, the basic. Suppose this is minus q charge and this is plus q charge. They are separated by a distance 2a. Okay, if this is the center of the dipole, then this is a and this is a. Now, okay, now we can take it a point at a P which is at a distance r from the center of the dipole. Now connect P and minus Q, P and plus Q. So in this case, we can find out the resultant electric field. Now the electric field due to point Q is E1 is along the negative charge, along the direction of negative charge, and the electric field due to Q is outside the, along this direction is E2. So the resultant is along this direction E. If this angle is theta, so this is an alternate angle theta, and this is theta, then this angle is also theta due to similar angle. Okay, so if we take the electric field E1 for minus q charge, we can get it as 1 by 4 pi epsilon naught minus q or q divided by the distance, that is, if it is say a point A and this is B, then AP, which is AP, a square plus r square. This is A, so this is a right angle triangle, so this is a square plus r square. So r square plus a square to the power half. Sorry, q by r square to the power half, not a r square plus a square, because that is q by r square. So it is E1 and the direction is along PA. The direction is along PA. and E2 is 1 by 4 pi epsilon naught, that is the electric field due to positive charge is E2, that is Q by, again Q by R square plus A square, but the direction is now BP, along BP direction, that is the outside the positive charge along BP direction. So as we see that the magnitude of E1 and E2 are same, magnitude of E1 and E2 are same. So if we take the value of E1 along this direction and this is theta, so if we resolve E1 in two perpendicular direction, then this is E1, this is theta. So in this direction we can get E1 cos theta, and along this direction we can get E1 sin theta. Similarly for E2 is here. So if we take E2, resolve E2 in two components, then again E2 cos theta is along this direction and E2 sin theta is along upper side. So E1 sin theta and E2 sin theta are equal, as the value of E1 and E2 are equal, and their direction are opposite, so they are cancelled out. So the resultant electric field E is equal to, so the resultant electric field E must be equal to E1 cos theta plus E2 cos theta. Okay. As E1 and E2 are similar, so we can get 2 E1 cos theta. Now put the value of E1 and cos theta, we can get the resultant electric field at an bisectoral or equilateral position. So the resultant electric field E equal to 2, E1 is 1 by 4 pi epsilon naught Q divided by R square plus A square, and cos theta, what is the value of cos theta? If this is theta, this is base and this is hypotenuse. So A divided by again R square plus A square, R square plus A square to the power half. So we can get 2QA, 2 into Q into A is P, 1 by 4 pi. So we can get 1 divided by 4 pi epsilon naught P, 1 by 4 pi epsilon naught P divided by R square plus A square to the power 1 plus half, that is 3 by 2, and the direction is opposite to P, opposite to original dipole moment P, as the original dipole moment is from negative to positive charge and the original direction is from P to E, that is opposite to the original dipole moment. So we can get the value of the resultant electric field E. And now again, if R much greater than A, then we can get the value of E equal to 1 by 4 pi epsilon naught P divided by A square is negligible, therefore R cube. Okay. So in short, we can get that for short dipole, E axial equal to 1 by 4 pi epsilon naught 2p by r cube, and E bisectoral or equitorial, we can get 1 by 4 pi epsilon naught p by r cube. So we can conclude that E axial equal to 2 into E equitorial for short dipole. This proof is very often given in your HS exam. So we can now easily understand that is what is dipole moment, the electric field at an axial position and the electric field at an equatorial position. So in the next class we shall go with the torque and dipole moment and Gauss's theorem If you like my channel, please subscribe for newly interesting video. Thank you.